Hello all. The next set of instructions that we are going to see is instruction for block structured languages. Now basically the block structured languages are nothing but there are certain different set of blocks returned, and those blocks are then separated by using the different language specifications. So let's start. A class of high level languages in which a program is made up of blocks, which may include nested blocks as components, such nesting being repeated to any depth. A block consists of a sequence of statements or blocks preceded by declaration of variables. Now, this instruction for block structured languages, now whatever instructions we are going to study in this set of instructions, they are mostly, or it this instruction is provided from in high level languages, okay. And the instructions in this provide high level language support for functions that normally they are found in the high level languages. Means what? Block structured languages, they are providing a certain set of instructions for machine language support, and the functions and the functions that are used in this are normally found in the high level languages, okay. Now block structured languages means what? The program is made up of certain different blocks, and that block can be either as a component or nesting can be done of certain blocks, okay. So we'll see now what is, if the blocks are provided with a functionality of high level languages, then what do you mean by high level languages? A high level language is a programming language that is designed to simplify the computer programming, okay. Computer programming means what? It is high level because several steps are removed from the actual code. Whatever is the actual code, from that several steps are removed, and then that actual code is run on the after removing the several steps from the actual code, then that code is run on computer's processor, okay. Then most common programming languages are considered as high level languages. Now what are high level languages? Like C, C++, Python, Visual Studios, they are nothing but high level languages. And low level language is nothing but your assembly language is a low level language, because it is machine dependent language. The instructions that you require to write in assembly languages is directly understood by your computer, so it is termed as low level language. And in high level languages, it is machine independent. That means uh, that is on any machine that languages can work independently, okay. Now first instruction is the enter enter instruction. That is, enter is nothing but a instruction, but it is also what you say, specified, or it is specifically known as a enter a procedure. Means what? Entering, giving entry into a particular procedure or into a particular block or into a particular segment. That is the meaning of enter. So what does this enter instruction actually do? It will create the stack frame, okay. It will create a stack frame that is required by the most block structured high level languages. As you are dealing with the block structured languages, this enter instruction will create a stack frame, okay. And that stack frame is parallelly in hand required by most or several high level block structured languages. Now the second point, the enter instruction, it includes two parameters. What are these two parameters? The first parameter specifies the number of bytes of dynamic storage. Dynamic storage means what? The storage that is going to take place at runtime, okay. And that is to be allocated on the stack for the routine being created. First operand, just remember, it will specify the number of bytes of the dynamic storage. That dynamic storage means that is going to be created dynamically, that is for runtime, or at runtime, and that storage will be that will be used to allocate the stack for the routine that is being created by the enter. Okay, whatever the routine that is being created by the entered instruction, for that purpose the first parameter is used. Okay, and the second parameter corresponds to the lexical nesting levels, that is 0 to 31 of the routine within the high level language source code. The second parameter, just keep in mind, lexical nesting routine. The meaning of lexical means what? That mostly it is related to, or that mostly deals with the vocabulary of languages. Now lexical means what? There is n number of vocabulary of languages, and there is a nesting level. Nesting levels are there from 0 to 31. So the second parameter corresponds to the lexical nesting level, and that is from 0 to 31. It will correspond between these levels of the routine within the high level language. So first operand deals with the dynamic storage of the bytes that is to be allocated to the stack, and the second parameter deals with the correspondent to the lexical nesting level, okay, of the routine. Routine is created by the enter, and after the enter, after the routine is created, then the corresponding parameter of the routine that is dealing with the high level source code languages will be mapped to the lexical nesting level. That means which lexical nesting level it is actually matching from 0 to 31. Suppose it is matching from level number 4, then the second parameter will correspond to the level number 4. This you will understand when you will actually use the enter instruction. Then the next point is the it determines the number of stack frame pointers copied into the new stack frame from the preceding frame. Okay, whatever are the number of stack frame pointers that are copied into the new frame, they are determined. Okay, and how they are determined? From the previous frame. Now the BP, that is the base pointer or extended base pointer, that is EBP. If the operand size attribute is 32, you will use EBP, and if the operand size attribute is 16, then you will use the BP, that is the base pointer, and EBP is nothing but your extended base pointer. Okay, the base pointer is the current stack frame pointer. Whatever will be your base pointer, that will be your current stack frame pointer. Fine. In the enter instruction, no flags are affected. Now we'll see the example. Enter 25 comma 2. This instruction will create a stack of 25. Okay, 25 bytes at the nesting level 2. See, this is nothing but your nesting level, lexical nesting level 2. Whatever is mentioned over here, lexical nesting level from 0 to 31. So here in this example, what we have given, comma 2 means what? 25 stack of 25 bytes is created at nesting level 2. Then next is the halt instruction. Halt means what? To stop. So same it is doing over here also. The halt stops the instruction execution and places the 80386, that is your microprocessor, in a halt state. The halt instruction will put the whole and sole microprocessor in a halt state. Now, not just one part of your microprocessor, but the actual whole microprocessor will be put into a halt state, and no flags are affected in this instruction. Then next is the leave instruction. Now the leave instruction is exactly playing the reverse or the opposite operation of the enter instruction. See, it reverses the action of the enter instruction by copying the frame pointer to the stack pointer. Whatever is your frame pointer, okay, it will copy the frame pointer to your stack pointer. Fine. Then the leave, that is the leave instruction, releases the stack space used by a procedure for its local variable. What does leave instruction do? It will release, or it will empty the stack space. Whatever is your stack space, the leave instruction will empty that stack space that was used by a procedure. Okay, and for what it will release the space? So that for its local variables can use that space. Okay, then the old frame pointer is popped into the BP. Whatever will be your old pointer of the frame, it will be popped means what? Removed from your, it will be popped into your base pointer or EBP, and restoring the caller's frame. Whatever will be the caller's frame, current caller's frame means what? Whoever is calling the particular frame, that it will get restored. That particular frame will get restored. Then a subsequent RET, that is the return instruction, it will remove any argument pushed onto the stack of the existing procedure. A subsequent RET instruction removes any argument pushed onto the stack of the existing procedure. What, suppose procedure number 1 is your existing procedure. Okay, in that procedure number 1, whatever will be your arguments, no, they it will be removed. Okay, removes the, so who will remove this? The ret instruction, it will remove any arguments pushed onto the stack of the existing procedure only. It will not disturb any other procedure. Only the current or the existing procedure will be, only the arguments from the existing or the current procedure will be removed. The leave instruction does not include any operand. It is used alone. There is no operand used with along with this instruction. The leave instruction copies the EBP to the ESP. What is EBP? Base pointer to the stack pointer. Now, very important point. Leave instruction will copy the base pointer to the stack pointer to release all the stack space that is allocated to the procedure by the most recent enter instruction. Why it will, why it will copy the base pointer to the stack pointer? Because whatever is your base pointer, that needs to be copied in your stack pointer, so that it will be helpful to remember where actually its current location was, or current space was, or current pointer was. Okay, and once the EBP is copied to your stack pointer, then it will release all the stack space. Whatever will be the stack space, it will be released. And the stack space that was released, it was first allocated to the procedure by the most recent enter instruction. Whatever was your most recently used enter instruction, that procedure will be vacated, okay, or removed, or it will release the that particular stack space. So in this leave instruction, no flags are affected, because it is just going to play the opposite or the reverse action of the enter instruction, so no flags are affected. And this is an example how you're going to actually write the leave instruction. Just alone, the leave instruction is, as it is an instruction, so all instructions are written in capital letters. And as it is mentioned over here, a leave instruction does not include any operand. So it is not having any operand. Just you're going to write leave. When you write the leave, the current procedure, it will understand that the current procedure will be have to remove the space, or the current procedure where that stack is there, the stack space will be released with due respect to this leave instruction. Thank you.